Welcome to Innovate and React. I'm Kevin Hares, and today we will talk about how chemistry can solve another pressing problem of the shipping industry. For ships to move efficiently through water, they need to be smooth. Rough textures can increase drag and therefore require more energy to move forward. On the other hand, ships are also a perfect place for small creatures to attach to, and those can create unevenness on the surface of the ships. And today I'm with Dr. Christina Linke, who is a co-founder of Clean Oceans Coatings and solving this problem with innovative coatings. Hi Christina, welcome to the show.
Hi Kevin.
Yeah, I already mentioned the rough problems, but maybe let's introduce this biofouling, these creatures that attach to ships a bit more.
Yeah, as you mentioned, biofouling is the growth of algae and seashells on the ship hull, and it increases drag up to 40%. And this is causing an estimated annual damage of $150 billion.
Those are huge numbers.
Besides, cranking up emissions, right?
Yeah.
So
it's a double problem. It's more costly to do the shipping, but also for the environment badly. And these creatures usually attach to the hull of the ship, and one way would be to basically scrape them off regularly. But that's way too complicated for all those big shipping companies. So how are they doing this currently?
Yeah, so the problem of biofouling is as old as humankind, because we were seafarers all along. And since the 60s, we do have very poisonous anti-fouling coatings. Mm-hmm. They are designed in a way to wash off over time, so leaching microplastic and biocides into the ocean, or then with time degrade and then taking initial biofouling with them into the sea.
So they are basically protecting the ship by being poisonous for those algae and mussels and whatever to attach to, so they basically can't grow on the surface. Or how do they work?
Yeah, that's a claim from most of the big companies, that there will be no growth. Anyhow, life comes from the ocean and it is stronger. So any surface submerged will sooner or later have biofouling.
Yeah, for these big ships, or I remember when I was in these logs where you can move a ship in the rivers from one station to a higher surface, for example, then you can see all these stuff also growing on the side of the walls of these. And it's basically the same with the ships. But these coatings, so one way they are poisonous, which is when they leach the poison into the water, bad for the other living creatures in the surrounding. But you also mentioned microplastics. So are they some kind of plastic coating, or how can I imagine those?
Yes, paint is plastic. And they like these so-called self-polishing coatings. SPCs, they are designed to wash off over time, because for one, they need to degrade to constantly set free biocides. And the second part is to degrade over time when the biocide is leached, like to fall off and take initial biofouling with them. So to clean the vessel by falling off.
So they're actually meant to produce those microplastics, kind of.
They are meant to produce microplastic and leach biocides into the ocean, and it's the biggest legal pollution we do to our ocean. It's more than 100,000 tons per year.
Oh damn, that's a lot.
And by the end of life, more than 50% ended up in the ocean. So the big cargo vessels are typically coated every 5 years, and it's a few thousand liters per vessel.
Yeah, and all that basically after 5 years ends up in the ocean.
Yes.
Right. That's huge. And also, well, I think not really talked about that much.
No, and I mean, 90% of our consumer goods are transported via the ocean, and I think we all should know about this problem and be aware.
Yeah, and with your company, you're trying to solve this problem with a different kind of coating. So what are you doing differently?
Yes, we have a truly hard coating that does not wash off and does not leach any microplastics or toxins into the ocean. It is completely biocide-free, and additionally, it is completely solvent-free. Mm-hmm. And that means that we don't have any micropores from evaporating solvent, and making it a really close, smooth surface. And we have the lowest surface roughness value amongst anti-fouling coatings.
Mm-hmm. So making the surface so smooth that those creatures don't have anything to attach to and they cannot get stuck to the ship? Or how can I imagine that?
So smooth that you have a very, very good foul release effect. Mm-hmm. It's called foul release effect because the microorganisms can only attach on the surface. Since we don't have a porous structure, they cannot attach as good as on SPCs, mm-hmm. and therefore when the vessel is regularly moving, mm-hmm. it stays clean because it's like too harsh conditions. But since we're completely biocide-free, we don't prevent biofouling. Mm-hmm. But on the other hand, since it's like a tile-like surface, mm-hmm. it is super easy to clean, and even barnacles you can flip off. And this is typically you have to damage the coating mm-hmm. if you want to get rid of barnacles. This is very exceptional. Mm-hmm. So our approach is that you do have a very hard, a very durable coating. So our oldest test patches are 8 years old. So we expect at least 10 years durability instead of 5 years, and you have the cleanability if you have long idle times.
Mm-hmm. That would already reduce the amount of coating necessary by half when you just do it after 10 years instead of 5 years. That's already a big step.
Yes, we reduce the OPEX a lot, but even more interesting and important for the ship owners is that with the super low surface roughness, we generate at least 7% in fuel savings. Actually, our current vessels that are running report 16 and 20% fuel savings, even much higher than we expected. Mm-hmm. And this is huge.
Yeah, definitely.
So, I mean, in shipping, bunker is your biggest cost factor, and when you have lots of biofouling, can be more than 80% of your operating costs can be bunker. And I mean, just right now, oil prices are cranking up due to the situation in the Strait of Hormuz. So even for 2% savings, ship owners install like these air lubrication systems and other stuff. Mm-hmm. So 7% is huge, and 20 is it's massive.
Yeah, that's also, as we said in the beginning, it's the other side of it. It's a double positive effect because it saves money by using less fuel, but it also saves a lot of greenhouse gases that are emitted, right?
Yes, and emissions as well from the solvents that we save, mm-hmm. because dockyards actually they have to report as well the solvents they use. Mm-hmm. So dockyards are looking forward for our coating as well. They can reduce emissions there. And
how are they using
for the dockyard?
How are the dockyards?
They are applying the paints.
Okay.
They are they are applying the paints, and then it's more safe for the dockyard workers to use because as well, end of life, it's not hazardous waste, it's regular waste. It's easier to handle, and it's a win for the ocean, of course. So we have multiple win situations.
Yeah, that's
we all win.
Really a great technology. And how did you come up with this technology, or your company? You're a startup, so it's like coming from new invention, I imagine.
Yeah, I must admit I just stumbled upon it. But as well, my co-founder, who did the research projects on the material initially, found this material by serendipity. It's a patent from University Kiel, mm-hmm. and there was a technology transfer company looking for applications for patents from the university. To bring them to real-life applications. And there was the idea to put this nanostructured patented particle into a polymer to enhance the polymer. Mm-hmm. And the result was, very sturdy yet flexible, which is necessary to perform good on a ship hull because, the ship hull is moving sometimes even 3 centimeters. Ship steel is moving meters in a storm.
Oh, okay.
They are really funny dashboard camera videos on YouTube for ship and storm. So this combination, looked very interesting, and because of the proximity to the ocean at Kiel, someone saw it and said you need to test it on a vessel. And again, because of serendipity, there were contacts to a very innovative ship owner who said, like, just come, I tell you when I have the next docking, and you can just apply some test patches. And 5 years later, this superintendent came back and told us, I saw these test patches in docking and it's amazing. When can I buy the product? And shortly after, I met this team on a conference for marine tech because by training, I'm a food scientist. I'm more an engineer than a chemist. But I was looking for a job with more purpose than just creating nice food. Which was great. But I was searching for more meaning. And ever since, I had a big heart for the ocean and marine biology and stuff. And so I tried to somehow find a way to change careers. So I was sneaking around on these conferences and they told me for the first time about this problem. And I was like, flabbergasted, like, why do we not know about this? And what are we doing there? And why is it legal? And then, of course, I was super relieved they have a great solution. And then it was like, but research projects are ending now. And then there is no more money. And we don't really dare. And so, it will end up in the drawer. And I think 1 week later was the first lockdown. And so with these thoughts, I was sent into the first lockdown and I couldn't rest. I was completely hooked. I was like, you cannot let this end just like this. And so we stayed in contact, and then in summer you could meet again. So we met a couple of times. And then in autumn, the second lockdown hit, and suddenly everything was possible remote because I was in Berlin, my co-founder was in Kiel, or close to Kiel, and nevertheless we started our first accelerator because what should we do? It's lockdown, and what could possibly go wrong? What could possibly happen?
It's a very productive way to spend this time.
And then everyone was from the very first pitch, everyone had the same reaction that I had at the conference, and we had great support from our very first pitch, and then there was no way back anymore.
I mean, this also what you just told me is really mind blowing, that we're putting so much poison and microplastics in the oceans, and that seems to be the status quo that is not really that much challenged and gives huge opportunities for new developments. And
it's even worse because we chose these coatings because they are the most toxic and because there is this product and there were the tests and there was this interest from the client. But overall, paint is plastic. And actually, the recent studies from the EU now as well verified the most plastic in the ocean, it comes from microplastic, from paints. And not all the other, I think we have sources in mind clothing and tires or stuff, but actually the most microplastic in the ocean comes from paint, and it's facade paints and road markings. So
road markings, okay, interesting.
And ship coatings is only 3%, but the most toxic one. But thinking of the empire I want to create, then we definitely tackle all the other paints as well. Yeah, that's at least that would be the dream vision.
So you actually also started with this biofouling as the goal of this coating, because this super smooth surface, as you mentioned, is also saving fuel by reducing drag. Is this then just a positive side effect?
It's a necessary side effect because with sustainability, we couldn't convince any ship owner. Without the fuel savings, we wouldn't have really good selling arguments.
Oh, okay. So saving the planet is not enough.
No, saving an ocean is definitely not a topic for ship owners. And I think for any climate or impact startup, it's not really like a good selling argument. So you need to solve a real problem. And luckily, the most poisonous toxins are forbidden since 2003. That's TBT, tributyltin.
Some tin compound.
Horrible word. Yeah. Because this was really devastating for the ecosystems. It's like because it had a hormonal effect and making lots of mussels unisex, so they were all female and couldn't propagate anymore. And so this luckily is forbidden already since 2003. And as you can calculate now, this is 3 to 4 docking cycles, 20 years now. And just now, the ship owners realized we do have a problem, because now they are largely using copper, and copper in these huge amounts as well, extremely harmful for ecosystems. So they get banned as well, more and more, especially in the Baltics, but as well in Brazil, Australia, New Zealand, Netherlands. So more and more biocides become restricted, and the less and less work the current solutions. And so there is really a need in the industry. And when you then even perform better than what they do have currently, then you get a foot in the door.
Yeah.
But not just with, look, this is better for the ocean. Try me.
Yeah.
It wouldn't work.
Yeah, I mean that you already can save half of the docking cycles is a big thing, but when you then also decrease the fuel consumption, then it's even bigger advantage. You already mentioned that it's a nanostructure, and can you tell me a bit more about how this painting works, or this coating?
Yeah, so it is a combination of this nanostructured particle and a polymer, and this is combining the advantages of ceramic particles and the flexibility of the polymers, which makes for these really nice features, being this sturdy and hard but yet flexible, and as well what I mentioned as well already, being 100% full solid system, so that we don't have any solvents that need to evaporate, and generating like this really close smooth surface and this superior surface roughness.
So a combination of several materials.
Yeah, it's a compound material, yeah.
Yeah, so a combination of 2 materials, like the ceramic and a polymer that keeps the ceramic in place, and together they form a very smooth surface. But this polymer, I mean, you already mentioned that the other polymers, they are meant to degrade, but you use a very durable polymer that's just not affected by these saltwater conditions, especially, which I imagine is also corrosive in some way.
Of course, saltwater is corrosive. And yes, of course, these coatings at the same time provide the corrosion protection for the vessel, for the ship hull. And it is, what I would say, coming with my cradle-to-cradle background, it is a last bad solution. It is not the perfect solution yet, because this is still fossil-based. Currently, we aim in the next generation to be bio-based and ideally biodegradable. Yes, I think, as you know, a big difference between bio-based and biodegradable. But John Warner, Pope of green chemistry, is very convinced that it's possible, because, I mean, being durable for 5+ years underwater and then suddenly biodegradable, I find it still very challenging. We definitely take it on, because I find it irresponsible and crazy nowadays to start a company being dependent on fossil-based material. But this will be a next step. So we need to prove our business case first with what we have now. Yeah. And then as soon as possible, we will further develop this. But I mean, in between my food science career and my startup career, I was at the cradle-to-cradle NGO. I don't know if you've heard about that principle, or if I should explain that briefly.
Maybe for those who don't know.
Well, it is a design principle where if you can't avoid that a material is going back into nature, then it needs to be biodegradable. If you can keep it in a technical cycle, then it should be fully recyclable. And it's a design principle very close to biomimicry as well, where like look into nature, you don't have waste, right?
It's all going
nature
around.
does not produce waste, and why are we humans producing waste? And why don't we look how nature is doing it, so we don't harm our life support system, right? So, and especially the ocean is our life support system. So this is definitely at the root core of our company and what we aim to design in the future as well with the other paints that might end up in the ocean, because this is, road markings and facade paintings, they are on land, right? But you cannot avoid that they end up in the ocean, so therefore they need to be biodegradable. And this is the whole principle, and this is where we want to go prospectively with our coating as well. But right now it's less bad.
Yeah.
So it's like the transition solution.
Okay, interesting. In this case, when you have a bio base, that I don't see a problem with this. Like there are more and more bio-based polymers coming up, or even with technologies where you can start with bio-waste or even CO2 and then create more or less all the chemicals that we are having in our chemical industry right now. But then they are not necessarily biodegradable. But with the coating such as yours, I imagine that biodegradable, especially in the ocean where a lot of microorganisms are around, biodegradable would then lead to a lower time in use, right? Or like this is for me a bit of a like working against each other, being biodegradable and very durable.
That's what I said as well, but as I said, our the Pope of green chemistry said it is doable, and so we will aim for this. Let's talk about this probably in a couple of years, then I can tell you more. I think the bigger problem is bio-based biochemicals at the moment is that you don't have them, you don't get them at bulk currently yet, and that they're not yet competitive in pricing. There's still a way to go. But yeah, it's definitely possible. Personally, I find it actually very irritating that the chemical industry, where they have two main cost factors, right? The one is energy, and the other is being fossil-based raw materials. And for the past 20 years, they did not do anything about it. On the contrary, they're pushing, lobbying Germany into dependency on cheap oil from Russia, and they could be. By now, they could produce their own energy already. They have such big buildings where they could put solar and stuff. And if these are my two main cost factors in my company, I would have changed that already.
Yeah.
I would have put much more effort into bio-based materials and being independent from energy and producing my own energy. And it's for free the whole day with sun and wind and everything. But, I'm not in the executive team there, and but it's funny because sometimes we get asked why are the big chemical players not moving? I don't. You ask the wrong person. You need to ask them, not me. I would do it differently.
I mean, there are also a lot of startups that trying to solve these problems and making more bio-based, also raw materials, but. Yeah, they need to scale first, and especially in this bulk chemicals and raw materials, it's all very price sensitive, and then it's more difficult to compete with these giants that have such a deep pocket and such a deep supply chain.
But that's the thing, they have the deep pockets, right? So they could invest in the future and in their future, and we do see it now. Like they are all very nervous about their future, where it's like, it's like you're driving with 200 kilometers against the tree, and there's just one tree. Yes, can move around it, or maybe two trees.
But that's a great analogy to see this problem. There are ways around it. Quick break. First of all, thank you so much for listening. I also like to listen to podcasts a lot in my free time. I notice that I'm sometimes missing the podcast that I'm waiting for in my suggestions. So that is why I created a newsletter for this podcast. So if you also would like to get an email when there's a new episode of Innovate and React, then subscribe to my newsletter. All the information to that you can find on innovateandreact.com/newsletter. Also, don't forget to follow on wherever you're listening. This really helps the show and helps me to get new guests on to continue. Thank you so much. Now back to the episode. Coming back to your coating and your solution is, technically I'm asking myself, why is this not everyone using this? Because it seems like a no-brainer to have a lower fuel consumption and even lower docking times. So what are the problems that you're facing?
It's not a problem, it's a challenge.
Yeah.
Of course, we only see challenges. Yeah. We don't have problems, of course. The challenge is to find the ones that go first, because their biggest fear, since we're a small player, we don't have many references, so their biggest fear is that the coating will fall off. They have an unplanned docking, they lose a charter party, and it might be a damage of a couple of millions. And so we're currently working on a solution how we can ensure that risk. So to take this last hurdle to get to the first customers coating full vessels with us, because more or less everyone, be it investors or customers, they want to see 3 big vessels moving around, and ideally, of course, with 3 years of superb data. And as you can see, this is hard to finance. And we are on a really good way. We do have smaller vessels going around with really good results. We are signing LOIs for bigger vessels. We are very optimistic by the end of the year to have the first big vessels going around. And big means like 100 meter plus.
Yeah. And they are probably also not that much comparable to like a small 15-meter ship or something. Because I imagine that for those, it would be not super expensive to change this coating. And maybe they are not really, because they're not these freight ships, they're not really dependent on this coating that much. So testing with those...
They all depend, of course, on a working vessel, if that's what where you make your money with. So one of our customers is ferry on Lake Constance. So if you want to see our coating in action, you can take Ferdinand, the catamaran, going from Friedrichshafen to Constance. Of course, he does not want... I think he is as well dependent that this vessel is going, right? So he can make his business. But of course, it is a lower risk than... just in terms of numbers, than for a big ocean-going cargo vessel or something like that. But still, even though this is a sweet water and it's a smaller vessel, we still see that these results help as well for bigger customers to make their decision. Getting there. It's just, it is a very conservative industry, and you have very long sales cycles as well as the docking cycle. It's 5 years, and 5 years in advance when the next docking will be. So even if you have or find someone who's super interested and will do this with you, but it is probably a smaller ship owner, then he might just have the next docking in 2 years, for example. We already as well, we do have customers, but the next docking is only in 27. And this is, of course, nothing that fits into the typical investment cycles of venture capital.
Yeah. So it's not that every day you can apply the coating on every ship, because they just go every 5 years into docking. When you have the coating on the ship, you mentioned that some part of the cleaning process is basically happening through driving or through going through the water, and it washes off basically the fouling basically from the surface by just going through the water. And other creatures like barnacles, they are a bit more sturdy and a bit more attached, but you said you can still clean them more easily?
Yes. So this staying clean while driving, this is like this so-called foul release effect. And I think it's rather an effect that with such a smooth surface and then such a strong current, it is just not a pleasant environment to settle. So it stays clean. And as to some degree soft fouling, let's start the other way around. As soon as a surface is submerged in the water, biofilm will start to form. And depending on the temperature and the growth season, this can be within seconds that you have the first initial biofilm.
Oh, okay.
And this is, of course, like biofilm is super soft. So with a foul release effect, you can clean this off as well. And already after a couple of hours to 2 days, you already have so-called soft fouling or microfouling, which are rather soft creatures, either like a beard algae, soft stuff. And then within a couple of days to a week, you already have microfouling and hard fouling. And this is barnacles, mussels, but as well like tube worms, other stuff that is building like more chalk-like structure. And once you have microfouling, you cannot wash it off anymore with a foul release effect.
Because they are then too strongly attached.
And then you need cleaning. Yeah, they are too strongly attached. And this typically happens in idle times. It's either, I don't know, like the case of Ever Given, was it, right? During COVID, when they for 2 weeks, they were all stuck because of this one
canal,
Ultramax. Then you sit there for 2 weeks in tropical waters. Every vessel has biofouling after 2 weeks in tropical waters standing around. No matter how toxic the coating. And this can happen. And then typically what they do is, they get diving companies or other robotic solutions to clean the vessel then. Because otherwise, it's this way too expensive to move that vessel.
And basically just manually scraping off whatever is attached.
Yeah.
And with the current solutions where they rely more on biocides, it's still attached to this, and because it's made to come off, the coating comes off with them.
Yes, even there was a test from the German government agency for water, like hydrography and shipping. So it's in German it is BSH, Bundesamt für Seeschifffahrt und Hydrographie. They did a study where they cleaned very, very soft. It was not even a brush. It was like where you scrape as well your shower with to avoid stains from water drops. These these rubbery things, soft rubber. They cleaned off soft fouling. And it is 4 kilograms for SPCs for a vessel of 150 meters or something.
So 4 kilograms of the
So each
coating.
cleaning, you take off 4 kilograms of coating with just a soft rubber, something to brush over there slightly. So it will be even more when you have to clean hard fouling from such a vessel. And what is even more interesting is and this is why the ship owners typically avoid as long as possible to clean an SPC, is once you cleaned an SPC, the surface is even rougher. You removed coating, so you shorten the lifetime of the SPC. The surface is rougher, and afterwards it will regrow even faster. And then you need to clean more frequently. And this is why they avoid it. And another thing is, and there we come to the regulatory point, and where we not just have a product for the market, but we need a full system changes, that because of the toxic coatings, cleaning is in most places forbidden. Because you wash off the toxic coatings with the cleaning, and it is simply forbidden. And so the ship owners can only clean in areas where environmental regulations are not that strict, like Panama and other places. And then even really just like people with just a snorkel and a mask dive down there and do this manually, which is as well not good for these divers to swim in these toxic coatings while cleaning.
So it's basically they just assume that all the coatings are poisonous, and that's why it's just generally forbidden to clean these ships. even if they would have
90
poisonous-free coating like yours.
Yes, and I mean 90% of the coatings used in the industry are still containing biocides. Yeah. Because 90% of the customers still use these SPCs, and another solution is silicone coatings. There are silicone coatings that are enhanced with biocides, and there are silicone coatings that are biocide-free, but overall it's silicone, and so it's rather soft, so they're not that durable against mechanical damage. And as like the same with shampoo and everything, these silicones are microplastic to the ocean.
In my head there would be like if you could put a stamp on the ship, basically having, so the people who have to clean ships can easily see, okay, this is a biocide containing coating, or this is not a biocide containing coating. Then but
I bring that to the next meeting with this roundtable biofouling, where they're talking about regulation, because so far there are only guidelines. And if you want to clean biocide-free coating, currently the ship owner needs to bring the proof and get an exception. And this is several steps that making this transition harder, because this is like they are making or want to make the better choice, and they are like punished with extra paperwork and permissions and stuff. Where it should be the other way around, right?
So get a permit for the other way.
When I bring this topic up, I'm like the most evil person in the room, and it's big. How can you make such a suggestion? It's like, because everyone's still using SPCs, you cannot turn it around and put all the other, like 99% of the ship owners the problem to have to to get permission for toxic coatings. It's like, well, but this is what we should do, and this is what would bring the change.
Yeah, that reminds me a bit of a problem from the hydrogen world, where I'm also working on. There's like, when you use hydrogen as a fuel with a fuel cell, it's exempted for these taxes that you have to pay for the emissions. It's exempted for the emission tax. But when you burn hydrogen in a hydrogen engine, you still have to pay those taxes, although there is no CO2 involved. Similar weird regulatory thing,
The lobby for the current solution is still bigger, but we're getting there. And it's funny, because on the other side, you have Australia and New Zealand, and they have a new biofouling management regulation that you need to clean before you enter the harbor, but more because of the invasive species you bring with a fouled hull. There's another dimension to this whole biofouling problem, which is invasive species, destroying ecosystem with bringing species to places where they have a competitive advantage over the local flora and fauna, and just spread and kill other things. And New Zealand and Australia are the strongest to protect their ecosystems. But on the other, so they have these regulations. Nobody has a cleanable coating. They don't have the cleaning solution in place either. They don't have the resources to really enforce this regulation, but the regulation is there, at least.
That's a starting
point. So
point.
all the regulations moving in the right direction, but it's still very flawed, and it's not to a point that it's really igniting a big, huge change. And as well, there are automatic cleaning solutions on the horizon. So there are many, many startups as well working on cleaning robots. And I'm completely convinced it will be the future. You will have a cleaning robot on your vessel, like we have cleaning, like vacuum robots at home, or mowing robots. It is going to come. And for this, you need a hard, durable, and cleanable coating solution. And several big players in the industry confirmed as well that this is where we're heading. But unfortunately, it's not there yet. And unfortunately, the shipping industry is rather slow. And this lack of speed, of course, is killing startups and innovation. Because as well, I mean, another question you have not raised yet is, and what probably, because we typically get lots of interest from private ship owners, because they coat their vessels themselves, they know how disgusting these toxic coatings are. And they typically love water as well. That's why they have a ship or a tiny sailing yard or whatever. We need to get to big volumes fast to be competitive with other coating companies. And in the private sector, it is even stricter regulated for the ship owners. With cleaning and everything. And unfortunately, private owners, they stand around most of the year because they only make it a couple of weekends to the vessel. And so they would definitely need this cleaning solution as well, but the cleaning solutions are not there. And in private marinas, it's much stricter regulated and controlled. And so this is as well not a way we can go to first enter via the leisure market.
Yeah, that was what I was thinking about with these super small ships, where there's also one ship doesn't need that much of coating. So you would have to sell to a lot of ship owners to sell the same amount of coating as for one giant container ship.
Yeah, so we definitely aim to install these kind of hubs so that we have dockyards that can apply our coating, because as well our coating it needs to be sprayed, so you cannot paint it by hand yourself. So that we have dockyards that are capable of applying the coating, and that we have cleaning hubs so that we can all offer this. But this is not something that we can pursue now. This we aim for 27 and onwards. But yeah, there's lots of interest from private owners.
Offering a package deal where you can get the coating and the cleaning and everything out of one hand.
Yeah. But it's not just selling a product, right? It's setting up a hub, and as well
the service
in these locations, as well working together with the local governments. Is it? So yeah, if it was easy, anyone else could do it and would have done it, because this problem is really as old as humankind. And in Europe alone, over the past 2 decades, there have been 50 research projects, and from this, I think 4 or 5 startups were generated, and none of them made it so far.
It's a slow market, and also very risk adverse, and then that makes it for startups more difficult, I would say. But still, if you have a great solution like yours, then you have a chance.
Yes. And the good thing is that finally, slowly, digitalization is coming to the shipping industry as well. So the shipping industry is even slower than Germany. I did not know that there was a space less digitalized than Germany, but the shipping industry is. And most of the ship owners did not know the full extent of the biofouling problem, because there was as well just a study from 2018 only, demonstrating that the first initial 0.5 millimeters of slime increase emissions already the first initial 25%. So you have the highest increase in emissions with the first initial 0.5 millimeters of slime, which is crazy. And like when a ship owner sees slime or biofilm on them, it's like, it's clean. Or any kind of soft fouling, it's not severe. And typically they all operate 30% above the baseline, what the vessel should be able to operate on. And I know that the most innovative shipping companies, they started having fleet performance manager starting from 2017. This is not too long either. And in a big shipping company, such a hull performance manager or fleet performance manager could save a company 30 million in the first year with just more frequent clean. And this is probably like every 6 months cleaning an SPC.
That's huge.
Coated vessel. That's huge. And they are still 10-15% above the baseline. But they only only know that they are more digitized, and that they have more performance data, and that they can see this and better evaluate it. It is coming more into their mind, and as well with CO2 certificates, of course. So they have much more pressure to decarbonize, and they realize more and more how much you can already do with really taking care of your health performance management. and all these things like the regulatory changes, the digitalization, the rise of the robots, all this is leading to the change. But this is already ongoing now 20 years. So it is, unfortunately, it is a bit slow industry, but it's getting there.
Yeah, that's great to hear that they, although slow, but they are moving. And I think it's very brave of you and your co-founder to start such a company in such a challenging environment.
Well, we didn't know that it is that challenging because we were out of the box. We didn't know what we get ourselves into. I don't know if I would have been the same like everyone else who kept telling us, you're not going to make it, it's insane. If I had more knowledge about the two industries, like chemistry is, like the chemical industry is moving slow and there's just these few big players, and the shipping industry is the same. I think it was maybe a little bit of an advantage that we've been out of the box and not knowingly jumping into these challenges.
Yeah, but that sometimes help to basically think of new stuff.
I think it's one of these typical cases where it's like, everyone said you cannot do it, and then there was these two, they did not know about it and just did it.
Exactly. It's a different perspective that you bring that those who are already in the market maybe don't really have, and then you think of different challenges that can be, with this new perspective, solved in a innovative way, which others thought would not be possible.
Yeah, absolutely.
And from this, do you have maybe some tips for other scientists who would like to maybe not necessarily enter the shipping market, but in general bring their research to the market?
I would definitely see where at my university I can find support for founding, because I hope so, at least by now every university should have these kind of hubs where they support founding and entrepreneurship, and especially for chemistry and green chemistry. I recommend Berlin and the Green Chem community and the Chemical Invention Factory to get their support. They opened their first Innovate call, where I think it's the best program you can find, because it's completely equity free, it's completely philanthropically funded, and they have a really strong accelerator program behind it. And it's funny because I'm a little bit as well giving a birth to this program, because we've been in Founder Institute as our first accelerator program, and they give all the business support in that program. And we've been in Inculab, where we found very cheap laboratory space, and they joined forces now to set up this really, really great program where you get laboratory space, you get funding, they even help with visa and housing, and you get all this entrepreneur and business input, what you need to have as a founder. And I'm super excited because I'm as well in the selection committee for the first batch now.
Oh, interesting.
Super excited what they're building there and who's coming, and what innovation the world will see from this.
Yeah, when you as the listener of this episode would like to know more about this, the Green Chem network was in one of the previous episodes, so there's more information on that. So basically reach out to these startup hubs at the universities, and that's where you find people who can support in, tell you what to do and what to start with, because for me as a chemistry student, when I started, that was not really part of the curriculum, and there was not that much about startups at all. So that's a good way of getting to know the people and a network. Yeah,
and it is so important that we make more use of all the patents that we generate in our universities. And Yeah, and it is a shame that so much ended up in a drawer. So really, if you have a good idea, go there. You don't even need to be such entrepreneur, because there are other people looking for the great ideas, but who are really driven entrepreneurial. And it's always good to find a co-founder with this business perspective and not just be a fully scientific team. Mm-hmm. So yeah, it was not my dream to become a founder. It was really, and I think 2 years before Clean Ocean Coatings, I was still, really don't want to be self-employed or somehow entrepreneurial. I don't dare and stuff. And these programs can really help, because once you realize that you might have rocket science innovation in your lab, but all this entrepreneurial stuff, typically you deal with challenges someone else solved before already. And you can just ask, and typically you get help out there. And this is, even though it might be very alien to you right now, as a brilliant scientist mind, there's nothing you can't learn there and get support with. And yeah, this stuff around entrepreneurship, you can definitely learn as well, or find other people who like them more and join forces.
Yeah, definitely. I think that's very important, that this founding a startup is not a one-man show. You have to cooperate, and you can also, as a scientist, it might be a bit frightening to get in this entrepreneurial world, and also regulations and all this kind of stuff. And then it's best to partner with other bright minds, and then you can really move something like you did.
Yes, and typically in entrepreneurship, you always have the analogies with relationships and partnerships and marriage and getting children and stuff. And as sketchy as I find them, I must admit they're super true. So, and how you say, like, it takes a village to raise a child. It's the same for your startup, and co-foundership is as well like marriage, because when you found a company together, you're tied by a legal contract, and it's actually harder to untie these than a marriage. Especially once there was already a valuation or something. Yeah. So these, even though I have these, this analogy actually is somehow true, but getting to more of the positive aspect, I want to rather highlight this. It needs a village to raise a child, and the same applies for your startup. And so get all the support you can get, and have strong network, and this will carry you.
Yeah. Also gives the motivation to carry on. When there are some, like in every research projects, there are some hard times where nothing seems to work, and I imagine that's similar in startups. And when you have a good team,
yes,
that really carries you forward.
Yeah. So if even before considering probably building a company or something, because I remember as well back from the time that I was a more nerdy scientist, as well, networking can be learned. Yeah. So you probably start with networking first.
Definitely.
And then see what it brings. But I think this was the most important learnings that I needed to make in my life is to ask questions, and not to be afraid to ask questions, and start networking.
Yeah, knowing the right people really helps.
And if you have an idea, then tell as many people about it as possible.
I think that's also contrary to this cliche that when you have a great idea, you must not share it because someone else might take your idea and start it.
Well, of course, you need to differentiate. Like, can I talk about it? Because if you want to patent something, of course, it cannot be published before. Yeah. But just having an idea, well, there is, as well, like in our case, there are so few people who would dare try it. Yeah. It makes much more sense to talk about it with as many people as possible, because only that way you find out if it interests other people, if it sparks interest with potential customers, and if you can find like people that can open doors or bring other ideas to it. I was, for example, super surprised. I just did not think about it before, but many investors actually own ships, because rich people and only rich people can afford to have a ship, but then they have probably coated themselves, and they do have an intrinsic motivation to support me, even though they might not see it as an investor case, but they really love the idea and support other ways or whatever. So you never know what connection can lead to something meaningful. and this is why you should talk with as many people as possible. And there are only very few people that would be so crazy and just change their whole life and take your idea and it's crazy. No, it's so super unlikely to happen, and it much more makes sense to tell as many people as possible, to get feedback, to get ideas, to get connections, and to get support.
Yeah, definitely. Thank you for that insight. And now we can come to the closing question of this episode, which is again, what is your favorite discovery in chemistry? I know you're not a chemist, but still.
Luckily, you sent that question beforehand, because this is actually how I would start the answer. I'm not a chemist by training. I'm more an engineer. So I had, there's always, so funny, when you have physical and chemistry, then the physics people always say everything is physics, and the chemistry people say everything is chemistry. Yeah. And then especially in my case, I had to deal a lot with physical chemistry. So I'm definitely not taking one of these. I think I think both have a point. But what intrigued me the most actually is biochemistry, because I don't believe in a religion or anything. But when I was in these biochemistry lectures and figured out what all has to come together and into place, that it's possible for us to live and this planet and everything, and how these tiny electrons jumping here and there, and how our body is generating energy and all this stuff, I find this is the miracle. And there I felt like this awe feeling. I think that other people have when they can truly believe in a religion or something. Yeah. It's not that I'm believing, but it's just this awe before creation, and that it's possible for us to live here. Yeah. And it's such an amazing, nice blue planet. It's not a discovery, I think, it's in itself.
Yeah, but the concept.
I don't know if you thought of some invention, a life-changing or humankind-changing invention, but this is just something that came first into my mind with this question, that I really find it amazing.
Mm-hmm. Yeah, definitely.
And as well, that our brain, that we can analyze this and figure this out, and this whole thing.
That's
I find it
super fascinating. And also, the more advanced our instruments get, the more stuff we can find, and there's always more to discover. That's really mind-blowing. The more we look into it, the more new findings we get that help to improve lives, find new medicines, for example. And that's really fascinating.
Yeah, the deep sea is actually very interesting as well. So many corals and other deep sea organisms creating really interesting substances that could help us in medicine and stuff. Yeah, all these kind of things. But these are discoveries as well, right? Mm-hmm. Like the latest discovery there was, I think, from octopus something. And this is actually as well super, they are chromophore skin. Mm-hmm. It's like they are seeing with their skin. And this is how they can mimic and take up all the colors. I don't get it completely, but the recent discoveries about the octopus is changing color and how it's perceiving the environment with the skin, so that he can do that actually, and how these chromophores in his skin are working. There's something super inspiring as well, and crazy. It's like, whoa.
And as you said earlier, everything is somehow explainable by chemistry and physics. And that's why it all makes it also very interesting to be in this kind of research. Yeah, thank you very much for all these insight and this very interesting discussion about your company and the biofouling prevention. Thank you very much.
Thank you for having me.
If you get interested in sustainable ship coatings, check out Clean Oceans Coatings website with the link in the show notes. Also, thank you very much for listening. Please hit the follow button on wherever you're listening. This really helps more than you think. And contact me if you want to talk about your research in one of the upcoming episodes. Either send me an email to contact@innovateandreact.com or connect with me on LinkedIn. Until next time, keep innovating and stay curious.